this video, I'm going to be talking about digital waveforms. Under digital waveforms, you need to understand that in binary systems, binary systems, information appear as waves. In binary systems, information appear as waves. In binary systems, information appear as waves to start with. And these waves can be decoded. Information appears in waveforms, and these waves can do what? Can be decoded to bits. So the first concept to look at is a clock. Okay, the concept of a clock. What is a clock in digital waveforms? A clock is a regular pulse or periodic pulse. It's a periodic pulse Okay, so a clock is a periodic pulse in which each pulse is equal to 1 bit time. The clock is a periodic pulse in which each pulse is equal to 1 bit time. Okay, each pulse is equal to 1 bit time. So if you have a regular wave like this here, and you call this one our clock, 0 and 1, right? You call this one our clock, 0 and 1. Then below here, we're going to have a bit sequence. With bit sequence. So from a bit sequence, we're going to have a bit sequence like this. Yeah. So if you plot this, plot that, plot that, plot that like this, plot that like that. So it means each pulse is equal to what? Is equal to 1 bit. 1 bit sequence in this case. Each pulse is equal to what? Is equal to 1 bit sequence. That's what a clock is. A periodic pulse in which each pulse is equal to what? To 1 bit time. That is what a clock is. A periodic pulse in which each pulse is equal to 1 bit time. That is what a clock is. So we come to the concept of a timing diagram. A timing diagram. So what is a timing diagram? Timing diagram is actually a graph. A graph for what purpose? A graph that shows relationships. That shows relationships. A graph that shows relationships among waveforms. A timing diagram is a graph that shows relationships among waveforms. For instance, we have a clock this way. Clock going this was a regular wave. Okay, and we're going to have our first wave that represents some sort of information. It might be looking like this. We can have a second wave that might actually be looking like this, and looking like this, and that, and like this. C might have another wave that looks like this. So a timing diagram is a graph that shows relationships among its waveforms. So from the clock, we'll be able to tell that at this period of time or that other period of time, when the clock was up, A was down and B was up, and C was what? C was up. When the clock was down here, A was down, also was 0, and but B was 1, and then C was what? C was also 1. So the clock helps us to determine the relationship at what time the A was up, or B was up, or C was up. So that's a relationship that they share with what? With the clock. So this is all you need to know about digital waveforms, starting from a concept of a clock and the concept of a timing diagram. So most of the information that you have here, you might have to put the information in most cases in a truth table. Okay, so that's all you need to know about clocks and timing diagrams under digital waveforms. The Prince for Computing 1.